Hexadecimal, you tell me you know nothing about it. So that's what you've told me, haven't you?
Yes.
Okay. So we'll try and make it clearer for you. Binary is a what base number system?
0 and 0 and 1.
Base 2. Base 2. Which means what?
Only 2 numbers, 0 and 1.
Beautiful. Zeros and ones. Okay. What's the number system that you're familiar with?
Hexadecimal.
You just told me you didn't know anything about hexadecimal. What do you count in every day?
Natural numbers.
No, natural numbers?
Yeah.
Or base 10? Decimal, denary? Yeah. Denary. Or decimal. Or dec. Yeah. No December. Yeah. Base 10. And of course, base 10 starts at 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. Stop. Okay? But then we've got a third number system, hexadecimal. Hexadecimal. It's used primarily in, it's used for MAC addresses to determine the sort of the unique identifier of certain hardware that connects to the internet, but it's also used for web colors. And you may have seen it in web colors. Usually a hashtag, and then maybe a 6-digit number, like so.
Yes.
Yeah, you've seen this?
Yeah.
That represents, now this
The color.
represents R, this represents G, and this represents B.
RGB, yeah.
Green, blue. Okay? Hexadecimal. You've seen it before.
Yeah.
Fantastic. So X, or hexadecimal, base 16, and this goes 0, exactly the same as base 10. 1, 2, 3, 4, 5, 6, 7, 8, 9.
What do we mean by base 16? Or base 10, base 2?
Do you know, I don't honestly know. It starts at, it's got two, is it like, could you argue it's like baseball? It's got two bases. You run for, like cricket, you run from one end to the other. Whereas base 10, you might run around turns. I'm going to pretend it's that. I have no idea. Yeah? Maybe that. Base 16, same as that, but there are 16 characters. Okay, we've got 10. So now we're going to go A, B, C, D, E, F.
So that's why it's 16 then.
That's why it's 16. That's why I've got an F there. F, I'm going to colour this in a little bit. F, or A, represents 10, 11, 12, 13, 14, 15. Okay? 15 being the biggest number. Okay?
Yes.
So, where do we go with this? So we've got web colours. I'll do it in the UK style of spelling. Web colour. Okay? But we need to convert, or part of the syllabus is for you to convert between hexadecimal, binary, and base 10. Okay? Now I've got, if you've seen any of the Star Wars films, I think it was episode with what's the name in? Rey, one of the new films. You may have recognised this little robot. It looks a little bit like this, and it's got a little thing there, and it's got a little circle thing there, and a little thing here, and it whizzes across. Has he got an eye? Maybe he's got an eye. No, he's got some headgear. We've got B8. Okay, it looks sort of like that, BB8. There we go. It's more like the Death Star. Yeah, BB8. BB8 could be described as a hexadecimal number. Okay, BB8.
11, 11, 8. Or
Good. Good. I'm just going to move that down a little bit. B, 8. Now, in a, I'm going to run out of space quite quickly. Let me reduce the size of the pen. Yeah. In a base 2 number system, we did 1s, 2, 4, 8, 16, 32, thank you for joining in, 64, 128. Okay? This being 2 to the 0, yeah? 2 to the 1, 2 to the 2, 2 to the 3, etc. Base 10, we go 1, which is basically 10 to the 0, yeah? 10, 100, 1,000, yeah? 10,000, and so on. Can you remember from the previous videos where I put numbers in?
Yeah.
Now, base 16, we've got 1, 16 to the 0, 1, 16, multiplying times 16, same as this, multiplying 10, multiplying by 2. So 16 times 16?
It has to be 100.
256. Okay? And then 16 times, not that we've got this, push it to BB8. 16 times 256,
No idea.
4,000,
Wow.
4,096. Okay, 4,096. This, in theory, this shouldn't come up in terms of hexadecimal in an exam. Why shouldn't it not come up? Because you are not allowed to take a calculator into the exam.
Yeah, makes sense.
So if we're talking silly big numbers, although you can do multiplication, I'm sure you can do long multiplication, that poses a bit of a problem. So what this means is, and why I've written these numbers over the top here, is like in a base 10 number system, where we've got hundreds, tens, and units, and if I have the number 3695, I've got 5 lots of 1, 9 tens, 6 100s, and 3 1000s. Okay? We're chunking it together, yeah? But we get the number 3695. Here, I've got B lots of 256, I've got B lots of 16, and I've got 8 lots of 1s.
So we have 8 1s, 16 Bs, and 256 Bs.
Yeah. But what's B in terms of hexadecimal?
11.
Beautiful. So I've got 11 times 256. It's quite a nice number, this. It works out quite nice. 11 times 16, and I've got 8 lots of 1. Now, if I add all those together, I'm going to get the decimal or the denary representation of BB8. 11 times 256 is
2,816.
okay, 2,816.
Plus 11 times 16 is 176.
Yeah, plus 8 should give me a total of 3,000. Yeah, good. So using this method, I can convert from hexadecimal to denary.
So this is basically converting hexadecimal to denary.
Yeah. But that's quite tricky in many ways. You might think, it's not quite tricky at all. It's dead easy. But there's an even easier way when we're converting to binary. Let's say I want to convert this to binary. The whole point of this number system is it's reducing the size of the characters. Hexadecimal is recognized by a computer, not in terms of machine code or really low-level zeros and one, like a computer uses zeros and ones, but it also uses hexadecimal to a large degree for certain things. Why? Because it reduces down the amount of space needed to take up particular characters. Whereas this particular number in hexadecimal, I'm going to show you in a minute, will take up 12 characters. In hexadecimal, it only takes up 3. In Denary, it takes up 4 character spaces. So we're reducing the size, reducing the amount of space that's needed. Okay, the biggest number represented in the hexadecimal system is 15, or F. Yeah? Okay. F, if we go back to, and I'm going to run this out for the time being. Okay, don't need that either. Think about 1, 2, 4, 8. Yeah? That is a nibble. Okay? A nibble.
The byte.
Yeah? A byte is 2 nibbles, or 8 bits. Yeah? 8 like an 8-bit register would be a byte. This is a nibble. If I put...
Oh, it's half of a byte, basically.
It's half a byte. But if I put 1s in here, what does that? What will that? This is the maximum I can fit in here before I have to go over to the 16 into the next sort of column. What's this number here? From binary to denary.
From binary to denary, if I'm not mistaken.
Let's add them together. 8 plus 4 plus 2 plus 1.
Oh yes, because they're all on. If one of them was off, then we wouldn't consider that as a sum.
Yeah.
So yeah, it's going to be 15.
Beautiful. That equals 15. So 1 nibble that's full, 1 lot of 8, 1 lot of 4, 1 lot of 2, and 1 lot of 1 equals 15. Hello. It's the same as the letter F.
Okay. So that shows that it's
So we can say that each number or letter in the hexadecimal system can be represented in a nibble. Yeah?
Yeah.
I'm going to prove that to you now. If I take BB8, we know it's 3,000. So 3 characters, 4 characters. I'm going to go and draw some little eyelashes onto each of the letters. 4 little eyelashes. Each one represents a nibble. So 1, 2, 4, 8. 8, 4, 2, 1. 8, 4, 2, 1. Okay, so with each of my little eyelashes, I'll put the little spaces in here so we can see that they're all going to be nibbles. Yeah? So, 8 is going to be 1 lot of 8, no lots of 4s, no lots of 2s, no lots of 1s. That's the binary representation of the number 8. Good. B.
So B is 11. So B minus 8 is 3.
Well, so it's, yeah.
Yeah, it's on 0, 1, 1.
Yeah.
This one is 1, 0, 1.
So it's as easy as that. Each of these represents a nibble. Therefore, I can just go 1, 2, 4, 8, and I can put the digits in. So you can see we've got the binary representation of BB8 as being 1011, 1011, 1000. Okay, 12 characters. So we've converted quite quickly between hexadecimal to denary to binary.
So there's no way that we transform the hexadecimal into binary directly.
Like that. So let's do a few practice ones. Or do you want to take some notes?
Yeah.
And I'll pause the video.
Yeah.
Okay.
And there's a low battery.
Yeah. So X is 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry, 0. Yeah. 9, A, B, C, D, E, F.
So 0 is also there?
Yeah, like in the base 10 system.
Oh.
we can only fit one digit in, can't we? So we don't go 1 to... you could argue we go 1 to 10, but we don't go 0 to 9.
Same thing for the denary?
Yeah, 0 to 9.
0 to 9.
Let's prove that to you. Okay. Units, tens, hundreds. I don't put 10 units in there. Do I?
No, you put 8.
I put one lot of 10 in a unit. No units, 110. Yeah?
Oh, yeah, I got it.
You got it?
Yeah.
Okay. It's all single digits. So X is all single digits. Base 10 is all single digits, 0 to 9. And then you could argue base 2 is single digits, 0 and 1. Yeah? What's that in there? I'm going to take an hexadecimal number first and turn it to, like we've just done, this is a recap. But then I'm going to take a denary number and I want to turn that into an hexadecimal. Yeah? So, we'll go, let's go the number A, B, C. A, B, C is going to be a base 16. Yeah, base 16, A, B, C. I can put a little 16 here, yeah, to show that that's a base 16 number. So, what I can do is I can say I've got my units, I've got my 16s, and I've got my 256s. Yeah. Now, note, based on what we've got here, 10, 11, 12, 13, 14, 15, you can see that A is 10 times 256 plus, as we had before, 11 times 16 plus 12 times 1. Okay, add them all together. 60 plus 176 plus 12 equals
2,748.
2,748. Okay? Base 10. Or a little 10 there. Yeah? So, that's how we'll do it like that. But again, remember we did the, to get it into binary, to get into binary, we're going to turn each one of these into nibbles. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. 8, 4, 2, 1, 8, 4, 2, 1, 8, 4, 2, 1. Yep. So, A is 10. B is 11. And C is
The 12.
Okay, so that's my representation in binary. Now what we can do, if I was being a little bit confused about this sort of turning it into base 10 to start with, what I could do is just omit the nibbles for the time being and go back to the old ways of doing binary, where I go, wherever I did before, 1, 2, oh, go funny, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048. Yeah? Would be a 12-bit register. Yeah, 12 numbers. So now I would go 2048 plus 512 plus 128 plus 32 plus 16 plus 8 plus 4 should give me that. Should we check it?
Sure.
Have you got Siri? Can Siri check it?
Siri? Hey Siri? Add these. Hey Siri? Add these values.
Siri, add the numbers 2048 plus 512 plus 128 plus 32 plus 16 plus 8 plus 4.
The answer is 2,748.
Beautiful. Thank you. Good. So that's that, and we've even done a check to see if we're all okay. Happy?
Yeah.
I think so. Good. Right. Now I have got a number, I'm going to go 155. No. Let's keep it simple. 55. And this is a base 10 number. Yeah. I want to convert 55 into hexadecimal. Okay? So, I'm going to put my little 1, 16, 2, 5, 6 up here. Now, obviously, 256 doesn't go into 55. So there's none of those. But we don't need to worry about putting a 0 in here, the placeholder. We just can focus on these two. How many 16s go into 55?
I think 3.
3. Okay. 3. I think 3 as well. 3 16s are 48. Yeah?
Yeah.
16 times 2 is 32 plus 16, 48. So how many have I got left? 55 minus 48 equals
7.
7. Good. So I've got 7 units. Okay? Nice and easy. It's a smaller number, but 55 in base 10 equals 37 in base 16. We'll do a slightly bigger number. We'll see how far we get. Okay, so I'm going to go now. I'm going to do another number, and this time I'm going to do 200 in base 10. Okay, how many 16s in 200? I'm guessing
7. No, 7 is 2.
if there's 3 in 50, i.e. 48, I'm guessing 12.
Yeah, 12.
Okay? So there's 12. 12. So I'm going to put a 12 under here, but you'll see why I'm wrong in a moment. How many's left?
8.
8. So 8 in there. But we can't have 2 digits here. Okay? Because that number would be on 128. So what's 12 in hexadecimal?
12 is C.
Beautiful. So for 200, the answer would be C.
8.
12 lots of 16, 8. Okay? 16. Put a little note there so you've got it. 12 lots of 16,
And how do we know when to put
8 lots of 1.
and then not to put 0 for 256? Why didn't we put any zeros?
Because we don't need them.
We don't need them?
No. Same as in binary. We don't have an hexadecimal register. The only reason why we would do it in binary is because we've got an 8-bit register. So if we've got this, yeah, this is the same number whether we've got zeros in or it's left blank. They're just sort of placeholders. So that would be the 128 position, 0. This number's still going to be 7, 4, 2, 1, whether it's that or whether we put zeros in or not. Okay?
So starting with 196, we can see that it's smaller than 256, so it's going to be off. And then if we're seeing how many 16s are actually in 196, we can divide 196 by 16, and it will be 12.25. So instead of putting the 25, we can just put 12. And now what we can do is that we can multiply 16 by 12, and we're going to get 192. So 192 is basically 196 subtracted by 4. So basically here's going to be 4. Now it's coming to 300.
But so that's the hexadecimal value in.
Oh,
So
my
there's
bad.
12 lots of 16,
Yeah, yeah,
there's
yeah.
4 lots of 1s.
Yeah.
But what's it in the hexadecimal?
I redo it or
No,
you
no,
can
no.
cut it?
What's 12?
12 is C.
Okay.
Shall I?
So,
redo
so what's favourite? What's that?
it? Okay.
Okay, so hello, that's good for me. Right.
So we can say.
So let's rub that mess out. Oh, there we go.
we can say C. So let's see here.
Okay, so C4. So then we don't really need that one, do we?
No, actually, we can just ignore it.
Okay.
But in this case scenario, we can
Yeah.
see that it's actually bigger, so it's 1. And so if we subtract 300 from 256,
You're using a calculator for that? Okay.
and we're going to get 44. So dividing 44 by 16, we're going to get 2.75. So we can arguably say that this is 2.
Yeah.
Now, we can say that 2 times 16 is 32. And if you subtract 32 by 44, we will get 12. Not 12, but C. So this is basically going to be our hexadecimal value, C4, and 1, 2, C.
Right. I don't know why you're putting lines in between them, so I'm going to rub that out.
Yeah.
We'll get rid of that.
Okay.
So it's just going to be C4 and 1, 2.
C4,
Yeah.
1, 2, C.
Beautiful. Superb. I think that will do. I think you know it. I think you've got it. Fantastic. Right. Bye for now. Yeah.
Sure, yeah.
If you're ready, I'll press start. Yeah, go on.
So we can see that 196 is 196.
So we're going to start with 196.
Yeah.
Right, okay.
Okay. Yeah. Shall I re-say everything? Because you can cut it, right?
Yeah, I can cut it. Yeah. So we're going to start with 196.
Please continue to ask questions, leave your comments, hit notifications, and please subscribe. And finally, if you wish to buy me a coffee, I'd be truly grateful. Please visit buymeacoffee.com/learning zone. Thank you very much indeed. See you next time. Bye for now.